Robbie go ahead and give her talk if she's ready to go.
Yeah, this is Robbie. Can you guys hear me okay? I actually had to go to a meeting at OSTP, and so when I left, I'm trying to find a place to sit to talk, and I'm in a restaurant, but it's a little bit noisy here. But can you hear me okay?
Yes, we can hear you.
Okay, well, we'll go ahead and go through the presentation. I really enjoyed sitting through Matthew's presentation, and I think that there's some definitely similarities between some of the things he's proposing and some of the things we're proposing. Let's go ahead and go to my second slide. And basically, what I want to do is give you an overview of the polar portfolio that we have in the Unmanned Aircraft Systems program within NOAA. And our job, we're part of the Office of Oceanic and Atmospheric Research, and our job is to evaluate UAS for operational use and research use within the agency as part of the larger NOAA observing system. And within our program, we have three main focus areas: high impact weather, marine and coastal observations, and polar observations. And so we picked the polar as one of the key areas early on, probably 7 or 8 years ago. And we could just tell that the polar regions, and especially the Arctic, are regions that need much more observations, and Matthew just highlighted many of those kinds of observations that are needed. So we have, if you go to the next slide, within our program, in those three science focus areas, we've also demonstrated a wide variety of different kinds of UAS technology. And these are pictures of the aircraft, but the way we talk about it in the UAS program is we're looking at observing strategies and how do you use these unmanned aircraft systems to collect observations that you can't get anyplace else. So in the left-hand column, we've got the Global Hawk on the top and the Predator on the bottom. Both of these are NASA aircraft, and those you could think of as a way to augment your satellite observations. These can carry remote sensors. They generally can carry dropsondes. They fly at much higher altitudes and can be, basically collect atmospheric profiling, remotely sensed observations of sea ice, those kinds of observations. In the middle are things I would say are the kinds of UAS that you'd want to use to augment, say, your ground observing network. So on the top middle is the Coyote system that can be launched from a NOAA P3 and treated like a glider under the aircraft to collect meteorological observations. In the middle is
Robbie, I'm so sorry to interrupt,
but please get the slides in order.
Yeah, what slide are you on, Robbie?
Oh, I'm sorry. I am on the second slide. This will be the UAS technology demonstration. It's showing the different aircraft.
Oh, okay. I'm so sorry. Okay, go ahead.
Yeah, I'm sorry if I didn't make that clear. But basically, the pictures in the middle, those are smaller platforms that could be hand launchable. The one in the very bottom in the middle can be lofted aloft with a weather balloon, and you can release it from a weather balloon, and it can glide down, collecting both atmospheric information and greenhouse gases and things like that. And then on the left side are some demonstrations that we've flown in the Arctic. One is using a Puma system, which is about a 2-hour platform that's hand launchable, can fly from a ship. And then also we funded a demonstration from some folks from the Pacific Marine and Environmental Lab in Seattle, who went to Svalbard, Norway, to partner with the Russians and the Norwegians to fly different UASs to collect air chemistry observations in Svalbard. So let's move to the next slide. This one should say addressing national and NOAA strategy. So some of our guiding principles that we've been using for looking at polar observations are driven by the national strategy, and especially the NOAA Arctic Vision and strategy. How can you better forecast sea ice? How can you collect better improved weather forecasting? But all of these would be based on how can we collect observations that you can't get any other way. So let's go to the next slide. This one should say UAS contributions. So for each of the NOAA Arctic Vision statements, I've got listed some of the activities that we've already tried. For forecasting sea ice, is there better sea ice imagery that will help with model verification? Once again, this could be collected from high altitude, especially in partnership with NASA, the Technology University of Denmark, and Environment Canada. They've all expressed interest in partnering with us on Global Hawk activities. We've worked with low altitude partnerships with the U.S. Coast Guard and Navy, especially from the Arctic Healy missions that have been flown the last 3 summers. And then right now we actually have a Puma system on a U.S. Coast Guard Polar Star that is down in the Antarctic, actually cutting ice for the National Weather Service. So each time we go out, we're gaining more and more understanding of what it takes to launch a small UAS from a ship and fly it under polar conditions. In the weather forecasting arena, once again, we're looking at how to collect vertical profiles of atmospheric information such as moisture and temperature and wind. And we've also been working with the low altitude well, once again in partnership with the Navy. Under the observing the processes, like I said, we've done air chemistry studies. There's many more things that we could do with smaller remote sensing instruments to get ocean color, low altitude observations of, say, methane gas from permafrost melting and things like that. Let's go to the next slide, which is also UAS contributions. And here again, under the improving stewardship, we're also working with our fisheries folks to learn how to use low altitude UAS, both from ship and land, to monitor marine wildlife activity and assessment, such as different kind of whale activities and ice seal activities. I would also say, as far as looking at how to respond rapidly to hazards, especially oil spills, we work with the Coast Guard on that. And that's especially something I think we should all be aware of, is how could we get observations in real time if there were some kind of important disaster in the Arctic. And then finally, I think, as Matthew said, I think there's a lot of both international and federal partnerships that we can explore working across agencies or across international units, especially in the Arctic. I think, especially considering the higher altitude aircraft, which are more expensive to fly, I think there's definitely, there could be avenues for looking at shared data and shared flight deployments among agencies. So the next slide is called U.S. Coast Guard collaborations. And this is just showing you some pictures of some of the kinds of activities we've done with the Coast Guard. We've actually done some oil spill simulations in the Arctic, where we've spread out green dye and monitored it with a UAS. On the right-hand side are actually some pictures of launching a Puma from the Healy ice cutter, and then below that is the actual picture from the Puma itself, looking at a search and rescue simulation experiment where there is a helicopter below the Puma, and then there's actually a simulated person, floating in the water below. So if we go to the next slide, here's a few slides I'd like to kind of talk about the Global Hawk in a little more detail, because I do think a lot of times people will immediately gravitate towards the idea of using smaller UAS, and they're definitely going to be useful and very versatile, especially for people in ice camps and with observing networks in the Arctic. But an aircraft like the Global Hawk, which flies at 60,000 feet and can carry remote sensors, that can be thought of as a roving satellite, and there may be, a need for those kinds of observations in the Arctic as we go forward. So the next slide is called the Global Hawk UAS Arctic Observations. And this is an experiment we did several years ago, and actually it was the first time we'd flown, either NASA or NOAA had flown the NASA Global Hawk to the Arctic. And we did an experiment where we actually flew just north of Barrow, and we were testing out our drop-on system for the very first time. And the data that you're seeing on the lower, basically the lower left, that is comparing data from two different drop-ons plus a radio song that was released from Barrow, and then also an environmental model run that was actually also done to compare. And you can see in general we've got very good correlation. What's really interesting is that below the altitude 1.5 kilometers, you see a lot of spread of the data. And that's actually showing that over those distances, between the drop zones, you actually have a lot of variability in the lower atmosphere. And how can we better understand that going forward? On the right-hand side, you're actually going to see the cross-sections of data. And in this particular flight, they actually flew over an ice lead, and especially in the wind direction, you can see how the wind direction changes with altitude in that very bottom right-hand picture. So let's go to the next slide, and I'll talk a little bit about some of the instruments that we can carry on the Global Hawk. The next one should say SHOUT 2015 Field Demonstration Payload. And within my program, we are actually working with the National Weather Service and NASA, and we're leading a project called Sensing Hazards with Operational Unmanned Technology. And this is looking at how to use the Global Hawk for better weather forecasting at sea. But many of these same instruments could be very useful in the Arctic. On the left side, we've got the drop-on system, and basically it can carry about 88 drop-ons. And once I said, it basically will collect atmospheric profiles of temperature, moisture, and wind speed and wind direction from 60,000 feet down to the surface. In the middle, we have a microwave instrument called a hamster, and that will collect moisture and temperature profiles across about a 60-kilometer swath, but then also vertically, also vertically from the surface up to the aircraft. So any place that aircraft is flying, with the hamster, you're basically slicing out a chunk of the atmosphere underneath the aircraft that is basically 60 kilometers wide and from 0 to 60,000 feet. The next instrument on the right is a Doppler radar system that is developed by NASA, and it's going to be very good at looking at precipitation structures, but then also wind speed and wind direction. Both of the hamster and the HIRAP work very well in cloudy and rainy situations. If we go to the next slide, which does other Shout Global Hawk payloads, I'll mention 3 other instruments that we've got under consideration for future deployment. One is called the Scanning HIS, and that's basically a clear air remote sensor that can collect temperature and moisture profiles from under the Global Hawk. And very similar to the hamster, it can collect over a swath of about 40 to 50 kilometers and can collect observations from the aircraft down to the surface. So once again, it's giving you a 3-dimensional slice of the atmosphere everywhere the aircraft flies. The next instrument is called the Hurricane Imaging Radiometer, and this is an instrument that is very good at sensing the ocean surface wind speed in high wind situations. So the way it works is as the wind blows across the ocean, it stirs up foam, and this particular instrument is tuned to be sensitive to that foam. So in hurricane situations or in gale force wind situations, say in the Arctic where you've got water, this instrument would also do very well as far as looking at wind speed on the surface. And once again, from 60,000 feet, it can give you about a 60-kilometer swath underneath the aircraft. It hasn't been flown in key ice situations, but it is believed that this due to the frequencies that this instrument has, it would be very good at looking at ice edges and being able to differentiate between water and ice regions. And finally, we have the Cloud Physics LiDAR, which is very good at looking at flying through the Global Hawk, but actually looking down to clouds and being able to map cloud top heights in a vertical situation. So I really ran through this quickly, and it's probably good for time just as well for all of you. But, you know, one of the things that we would like to stay abreast of for this collaboration team is to help us kind of guide our portfolio to make sure we're making the right investments that will be useful to the Arctic. And one of the things that I could, definitely help for future conversations are what are the if we were to prioritize observations, what would be the number one thing? You know, Matthew mentioned many observations, and I think many of these you could use unmanned systems to get at, but what's the first thing? So is it better to look at an interagency partnership so we can continue to get Global Hawk observations, or is it better to start investing in the lower altitude observations that could be flown from ships and ice camps and other things? So with that, I'll close and answer any questions. I want to thank you all very much for being patient with me and giving me a chance to talk with you.
Thank you very much, Robbie, for accommodating it while you were downtown.
No problem.
Jeremy, this is Hayo Aiken.
Go ahead, Hayo.
Yes, hi. Thanks for the great overview, Robbie. I just wanted to let you and others know, a quick reminder that as part of the Arctic Observing Summit, Arctic Science Summit Week, that we're hosting in March here in Fairbanks, that actually one of the thematic working groups is focusing on UAS technology and UAS operations internationally in the Arctic.
Thank you for letting me know that. Okay.
That's co-chaired by Cliff Sweat, who used to be with Federal Aviation Administration, now with the International Agency for Coordinated Flight Observation.
Oh, okay. Well, I knew him when he was at the FAA. I didn't know that he left the FAA. So yeah, that's great. I'll go ahead.
Yeah, he's actually, and what they're in particular interested in, the co-lead for that theme is Rune Storvold, who's heading the UAS efforts in Svalbard and at the Norwegian Norroot Institute, and they're interested in advancing a framework for making it easier for international cross-border operations of UASs in the Arctic. That's one of their key agenda items to address. So I would encourage you to get in touch. I'll send around a message as well here to the team with a link, that has some of the specifics. And we're just in the process of getting some white papers readied for publication as well on the website that have a bit more information on some of this.
Oh, excellent. Thank you so much. Actually, I know both Runa and Cliff, but I haven't talked to either one of them lately, so I didn't know about this particular meeting. But, yeah, I'll definitely try to make sure that a representative from my team can go to that meeting if I can't go personally. But I really appreciate it. Thank you.